Hello here, this is Jeff Erdman, E.D.S. Inc. Shandon. I want to welcome you here to our video tonight. We're going to be making some clamps for the faceplate of our that we're going to use to fasten materials onto the lathe. And I've kind of explained what my purpose was on these clamps before. I'll tell you what, I'll go grab the paper, I'll bring it over and I'll kind of show you the idea and some of my new thoughts involved with that too. And we'll start putting these things together tonight. Okay, hopefully you can see this without too much glare. But this is kind of what we're going to make. This is the base here. This is the top that'll move back and forth. And this is kind of a flat, looking down on the device. So we'll have some dovetails in here that these will interact with. That's right here, and slide along here. We'll have a bolt threaded through here that will push that back and forth. Now the new thought that I've developed is I'm going to be putting a slot in here that will allow for our bolts to fasten or clamp the object that I'm going to put on that plate. So the slot will allow for this to go on, that bolt to be there, and so we can make the part permanent on the plate. There's not that much room on the plate, and once we get these things on there, there's going to be even less. So we want to make sure that we can clamp that effectively down. So I thought, well, I'll put some holes in there, and that way, or slots in there, so we can do that. So anyway, what we're going to start with tonight is we're going to start with slotting this. We're just going to take and run 1 inch all the way through some square material that I have in the mill, and then once we get that done and down to depth, then we'll do the dovetails inside. And then once we finish that, then we'll go back to doing this. Now, this may take a few different videos, you know, I'm not going to be able to get this done tonight. It's too much for me to accomplish tonight. But we'll be able to make at least the slot in here, and I'll work an hour or so, and I'll let you watch me as we develop that. So I'll take you down to the material now, and I'll show you what we got going there. Okay, so we've got our part and our vices. We've got 2 vices trammed in, and we've put our part down on some parallels to keep them slightly above the vice jaws. And what I've already done, I made some marks on either side where or center marks. I've ran the cutter over the top of this, and I have determined that we are now dead center on this bar. So now we're going to go ahead and lower this. This is an aluminum bar, so I'm thinking that I can make the whole thing in 1 cut. We'll find out. If it lugs down, then we'll just have to start all over. But we're going to see if we can cut the majority of it in 1 cut. I've cut steel with 1 cut, no problem. So I think that we should be able to do that on this as well. I am going to go over and speed up the speed a little bit. I'm at 180 right now, and with aluminum you could cut a little bit faster. I'm probably going to take this up to about 350 and see how she cuts. So I don't want to run it too fast. I don't want to overheat and start melting to the tips, to the cutter. So I have to be careful of that. So I'm going to first do that real quick. So I'm going to set this on nudge in here, and we'll okay, let's see whether we got her running. Yep, she's a turning. So I decided to set it at 450. So we've got our machine set at 450, and my DRO is set at 0, so I'll know how much to bring her down. So let me go to my chart here real quick and read off what I need to take her down. My depth is going to be exactly 1 inch as well. So we're going to go ahead and take her down 1 inch then. That may be too much of a cut, but we'll try it. We'll see what's happening. When I made my tool post, I took about 1.5 inch cut out of that steel. So okay, we're at 0.85, 88, 9, 95, 97, 99, 5. Oops. Just a tad bit more. 9995. There we go, 1 inch. Yeah, let me just double check that dimension. Yeah, that looks right. Okay. Well, let's see how she does. Let's take her off of the nudging. Wet this a little bit. And we'll start her in and see what happens. By 1 slot through this metal. 1 pass. I'm going to run it back through just as a spring cut. Not that it needs it. Okay, we're heading out here. I don't like those pen needles chips, I can tell you. Much rather have these big chips you can pick up, and those are sweet right there. Those pin needle ones that it cut the last time wasn't very nice. So anyway, we've got a cut. We did a 1 inch by 1 inch, one pass. It's got a little bit of chatter in it, but like I said, I'm not looking at perfection on this anyway. This is not going to be a precise tool. It's just for adjusting materials on the faceplate. So next part of this will be dovetailing these two sides. So we'll dovetail those, and then we'll start on the part that slides into it. Okay, I've zeroed out my DRO. I've touched off here at the bottom. So now we're going to start our dovetail on this part. So right now I'm going right down the center, and we'll go all the way down the center and all the way through, and then I'll move it over. And we'll run it a little bit closer to one side, and then flip it and do the other side. Last made our female dovetail in our stock, and so what we had to do is measure these dimensions of this dovetail so we can make the male section that will slide into it. So I've determined, I don't know if you can see this on camera or not, but I've determined that the height of the cut from the top to the base of that cut is 1 inch. It's about a thousandth over that. Boy, my tongue is tied tonight. Across the dovetail I have 1.6397, and the little shoulder here above the dovetail is 0.470. So this dovetail is just slightly over a ½ inch in depth. So now we have to transfer that over to our other stock. So I've taken and I blued the end of this. I'll bring you in here. I blued the end of this, and I marked out where I have to cut out to get down to where I can then set up my dovetail cutter and cut the dovetail on it. And so this will be a reverse cut on the dovetail, so that it will then fit into here. So when I cut it, this is going to be, we better double check this. Yeah, this is going to be the bottom. And so when I bring my cutter in, I'll be bringing it in on both sides here to cut that dovetail out. But I first have to make sure that I get the right tolerances. So what I'm going to do is I'm going to go ahead and I'm going to cut out to the width of my dovetail. So I'm going to be taking out, I forget what that was, 0.43 of an inch off of both sides for that a little bit over a ½ inch cut here. And then it's a little bit under a ½ inch cut for this other section all the way to the neck, which is going to be slightly under 1 inch. The neck will be slightly under 1 inch. So we're going to do that first. We're going to take off that material. Then I'll set up to go ahead and cut these dovetails. So we'll take you over to the mill and we'll get started with that. Okay, so the first thing I did is I came in here and you can see that I touched off here on the top of my material. So I just got my height, and what I've done is I've went ahead and zeroed out my DRO. I actually just turned it on after I got the height. And now what I have to do is set my depth on the inside from this edge to this edge, the distance I want to cut. So that'll be the next thing I do. And then all there's left to do is make the cuts. Plunge down to the depth I want and make the cuts. I'll bring you back when we're ready. Okay, so I've locked down the bed. This is we're going to be taking a 1 inch cut here in width and 0.430 inches depth. And that'll get us right down to where we need to be for our dovetail. And then we'll have to slot the neck out. I'll have to see if I have like a 7/16 end mill, or otherwise I'll have to use a 3/8 and cut that with a 3/8. So we'll go ahead and we'll turn things on and get her running. This is what's left on that edge. It kind of is like maybe 1/1000 thick. I'm going to measure it and see what we got, what the left off is. And that's pretty thin. Not quite as thin as foil, but very, very close. Okay. I've got my bit touched off against the back here, and it's zeroed out off of the top here. So now I have to determine how far down into this I need to go. But before I do that, I want to mic this to make sure I got the right dimension. So we've got 1.6 that looks like 25, 26, 27, 1.627 inches. Now what was our mark supposed to be? 1.6397. We're within 0.010 of an inch, not even that much. So I think we're good here. So now what I'm going to do is calc what I need to take in this depth here. So I'll do that real quick and I'll get right back to you. Okay, I've got her set at 0.325. That's my depth. I think I've got her right. We'll give her a try and see what happens. And they are just as smooth as silk. Boy, I tell you, these edges are about as sharp as they can get. Okay, let's take it over and see if we can fit her into the other part. I'll probably, off camera, I'll probably take and I'll deburr these. We got a little bit of, I should file that a little bit too, because those are really sharp. I mean, you'd end up cutting yourself. It's like a knife. So this is our moment of truth. We've got our dovetail made. It's a little bit undersized, but this is for a clamp, so it's not quite that critical. If this was for a machine, you'd want these very nice and precise, but we're not quite that precise, unfortunately. But it's still going to work just wonderfully. There we go, and that's what we were after. We were after a combination so that this would slide, and it has a keeper, and so I'm not totally disappointed in that. We'll make that work. So anyway, what I wanted to do in conclusion here is share with you a couple of eBay finds. A couple of things that I found that I thought you might enjoy too is some publications. I ended up seeing this on eBay, this casting and forming processes in manufacturing. It's printed, its copyright date is 1950. It has no printing on the front, just on the binding, but it's filled with fascinating information and illustrations that portable type are really unique. Walkover pattern draw this has a machine. Pretty unique. I've never seen anything like that, and I thought you'd like to see that as well. But they have all sorts of illustrations in here of early manufacturing and how they achieved different processes back there in the 40s and 50s, and fascinating old machines that are still being used by someone, I'm sure, in some cases. So it's a pretty neat machine. Publication that I'll be able to use for reference. I found it very nice. This is showing how to do casting, how they did that back then, and set it up. That shows the finished casting and the way they poured it, the whole 9 yards. Kind of neat. Anyway, interesting, these old publications you can get. Another publication I got, excuse me, that I think you'll find very interesting is this one here. This is the Goddard and Goddard company. It's the tools that go and go. It took the first two letters out of their name and made go and go. So out of milling cutters. And fascinating, here they have a discount schedule just inside this book. And some of these things are net. Some of them you get an extra 10 or 15% off. But this was published back in 1947. And the name, it even has the distributor of their parts listed here. J.A. Greenwald of 3307 Superior Lane, Cleveland, Ohio. This was owned by Alfred Rebecki, I believe, of Cleveland, Ohio. And book is pretty near brand new. This is a picture of the factory there in Cincinnati, Ohio. The Go and Go tool manufacturer. They made a lot of mill tools. We can see pictures of those in here. Fascinating different cutters that they used even for the railroad. They have a lot of interesting tooling there that they use for railroad and reaming and what have you. And multiple threading tooling. Fascinating to me what they did there. But what's really kind of neat is in the back of the book, they go through a lot of information that's very beneficial. They have several pages here on cutter sharpening, how to care for your cutters, and then the proper procedure for cutting each type of cutter. So I found that really of interest. And then as you go through here, They have illustrations and charts that you can use. They tell you what sort of grinding wheels to use and what have you. Then they go back here and then they give you a lot of the standards, the different drives and what have you, different spindles, the tapers, and the National Standard taper shanks, the Jarno taper shanks, Brown and Sharp taper shanks, the Morse taper shanks, the Hilux end mill holder, Hilux end mill holders. And they give you all the dimensioning on those and the tapers on them. They have a hardness conversion table, and then decimal equivalents on the opposite page. Then they have all your thread standards, the American National Acme screw thread standards. It gives you all your pitches and thread depths and your flat bottom space, thickness at root of the thread, so on and so forth. The same with the American National taper pipe threads for pipe threading, American National form threads, Sharp V threads, SAE standard threads, ASME standard threads. So it's almost like what you'd find in a machinist handbook. So I can see where this would become a very nice reference tool in the future. So I was pretty happy to find this, and it's in, everything looks like it's hardly even been used. Maybe been opened a couple of times in its life. Probably just sat up on a shelf somewhere and wasn't used at all. The other book that I got is a necessity for me, in that, to be totally honest with you, I don't have much schooling. I didn't finish high school. I was failing in my senior year, and because I just wanted to get out and work. I didn't apply myself to education too much. Now I wish I really had done so. But I took what was called, at that time, it was brand new, in fact, it was 1975. They had what was called the high school proficiency test. And so I went ahead and I took that test, and the idea of that test was to make sure that you had a high school equivalent so you could move on to college. They were trying to get students out and move them on to college a little bit sooner. Well, I always had a good ability to take a test. I enjoyed listening to the lectures and all that stuff during class, and I could always take a test and pass it. Used to frustrate some of my teachers because I never turned in a lick of homework, but on their tests I'd always do well. So anyway, I aced the test, and I had an equivalent to a high school diploma, and so I got out about 6 months early out of high school and went right to work, which was a foolish mistake. I should have spent a little bit more time with my education. But anyway, all through high school, I just used basic math, basically. You know, I was more interested in construction at that time and framing and what have you. And although there's some geometry, jig, and all of that, there were simple formulas that I learned, and I didn't really know the math. I just used those formulas to do our calcs and what have you then. So I never really learned any of the deeper math. I never learned algebra, never learned trig, never learned geometry. So, with that being said, I went and I purchased myself this publication because I'm finding that I need this more and more as I move forward in my education of the machine world, and learning angles and what have you is really important. So I'm sure you can read that title. It's Trigonometry for Dummies. And since I'm the dummy, I found a book that will teach me how to do trigonometry. Now, my son, that boy was a genius in school.
Is the peanut butter jar open?
He he ended up second in his class. A girl beat him, which is typical. Girls are pretty smart typically. And so the girl was a valedictorian, and I forget what you call the guy second in command there. But at any rate, he had all sorts of honors in math and stuff. And so he started actually helping me a little bit with trig, and from what he remembered. And he was very helpful. It helped me when I was setting up my DRO and what have you, because I was really, I had no clue. The explanations that they gave in the book and what have you were beyond me. And so he helped me to understand the math process so that I could do my setups, which was very helpful. So now I'm going to learn on my own. I'm going to try to, I've already done some reading on algebra and that sort of thing, and I get that concept totally. I understand it. But I need a little bit more trig. And so I'm going to dig into that and learn that. So anyway, so those were some of the finds, and it's amazing what you can do if you apply your mind to it. And I encourage all of you to continue, and especially you young folks, to continue in your education. It doesn't have to be college, but keep learning, keep taking things into your head. It's a fascinating world out here. And our Creator put our heads on our shoulders for something more than just sitting there. It's not an ornament, I don't think. So we want to use it to better our world around us and help others as well. So you can't do that if you don't know nothing. So got to keep learning. Anyway, with that spiel, I want to thank you for watching E.D.S. Inc. Shandon. We're going to continue with these clamps in another video as we finish those up, and then we'll start making that hinge for the milling machine, and we'll do a finale on that. But thanks for watching. If you enjoy our content, please subscribe to us and follow along in our little journey here of millwork. Thanks for watching. If you like it, please subscribe. Thumbs up, please. And if you don't like it, you don't have to watch. That's the nice thing about YouTube, is you don't like the content, you can go on to somebody else and watch that. Anyway, I hope you enjoy it. I'm enjoying just doing it. So take care now.